Hello, Honors Geometry students. Welcome back. Today we're going to take a look at how to find the circumference and arc length of a circle. Since we piloted that reveal program last unit, this is going to be kind of a refresher for us. So we'll just take the day to refresh our memory and hopefully reinforce this skill that we had earlier. So if we're going to talk about the circumference of a circle, there are two different formulas that we might take a look at. C equals pi d, where d represents the diameter. Or the other one that we were working with and more often in our last unit, which is c equals 2 pi r, where r represents the radius of the circle. And when we're talking about the circumference, we're talking about if we're walking around the outside edge of the circle, how far are we going? All right, so cruising ahead. Example 1 asks us to find the exact circumference of circle A. Now remember, exact means no funky decimals. So we might have some different symbols hanging out in there. Remember, circumference we can either think of as 2 pi r or we can think of as pi d. In this picture, I recognize that 16 centimeters is my radius. So I'm going to choose to use this formula on the left. And I'm going to plug in 2 times pi times 16. Since I want exact, as soon as I type in pi into my calculator, it's going to be some gross decimal. So to keep it exact, I'm going to take 2 times 16 to give me 32. And I'm dealing with pi. And since circumference is a length, it's going to be 32 pi centimeters as our exact length. Now this is something like you would see on a standardized ACT test. Typically those answers are going to be shown in exact form. If you wanted to get a rounded answer, because we know on Blackboard we can't do, it's more difficult to type in pi there. If I typed in 32 times pi, my approximate answer would be about 100.5 centimeters. And I just get that by taking 32 times pi. All right, cruising along, another example. Here, the circumference of the circle is 12 pi. We want to find the length of the radius. So if I'm thinking about circumference and radius, I'm thinking c equals 2 pi r. I'm told right off the bat that my circumference is 12 pi. So I'm going to plug in 12 pi for c equals 2 pi r. Our goal is to get r all by itself. I'm lazy, so I'm going to take care of this all at once. I know it's 2 times pi times r. So I'm going to divide both sides by 2 pi right away, all at the same time. If you're doing this on your calculator, make sure you throw some parentheses around the 2 pi to make sure you're dividing by the product of 2 and pi. Otherwise, what your calculator does is it divides by 2, gets that answer, and then multiplies the whole thing by pi, which we don't want. 2 over 2 is 1, pi over pi is 1, so we're left with r equals. Pi over pi is 1, 12 over 2 is 6, and we're dealing with centimeters. Cruising along, we might come across something known as concentric circles. These are 2 or more circles that lie in the same plane with the same center. Both of these circles both have that same center, and it kind of looks like a bullseye. In this next example, we're dealing with concentric circles, and we're asked to find the difference in circumference measures of the large circle and the small circle. So essentially, we want to find the circumference of the big guy, find the circumference of the small guy, and subtract. So, if we deal with the big one first, I notice with that big circle, we have this piece 18 centimeters, and that is my radius. So I'm going to think c equals 2 pi r. So 2 times pi times 18. And I'm going to do this as an exact answer for right now. And I'm going to take 2 times 18, multiply those together, I get 36 pi as my exact answer. For the mini guy, notice I don't have my radius, I need to calculate it out. So I know all the way across is 18. I know this outside edge piece is 5, so 18 minus 5. I get 13 for my mini radius of that inside circle. So c equals 2 pi r again. So 2 times pi times 13. I'm going to multiply my 2 and my 13, my whole numbers, to get 26 pi. If I want to do my difference, I'm going to take 36 pi minus 26 pi And my overall difference, 36 pies minus 26 pies, is 10 pi. In this particular question, I didn't ask for an exact answer, so we could have chosen to do it in decimal form. If we were to convert decimal form along the way, we would end up with about 31.4, and I'm missing units for both of these, so centimeters. So it would be your choice in this situation because I didn't specify if it was rounded or exact. So 10 pi centimeters or 31.4 centimeters. All right, switching gears a little bit. All right, next topic, we're going to deal with arc length. We talked about circumference so far, that's the distance around the whole outside edge of the circle. Arc length, now we're going to talk about a portion of that distance. And there's two different formulas. You can think a over 360 times 2 pi r or a over 360 times pi d. Personally, I like to think about the arc length being equal to the fraction of my circle times circumference. Personally, it's easier for me to remember that setup rather than memorizing those mini formulas that go along with it. All right, so if we look at example number 4, where length equals fraction times circumference, we want to find, I'm just going to copy and paste that here. Okay, length is fraction times circumference. We want to find the exact length of AB. Notice again it says exact, so we're going to keep things in terms of pi, most likely. All right, AB. I notice that we have a central angle hanging out here, and it's marked as a 90-degree angle. Central, since it's touching the center of my circle, we think same. Just a side note here, remember last unit we talked about inscribed angles, so in case this comes up, if we have an inscribed angle where all 3 points of my angle are on the outside edge, let's say this is a 30-degree angle, I would multiply that by 2 to find my arc of 60 degrees. Remember, that's inscribed. All right, but that's not what we're dealing with here. We're dealing with this central angle, central same. And if I'm dealing with my fraction, okay, I'm dealing with 90 degrees, and the whole circle is 360 degrees. If I want to simplify that right away and call that 1/4, that's just fine. Now I need to also find my circumference. Now remember, in my toolkit, we have either pi d or 2 pi r. I notice in this example, I'm given 10 centimeters, and that's my radius. So I'm going to plug in 2 pi r, and 2 times pi times 10. If I'd like, I can clean this up a little bit and say 1/4 instead of 90 over 360, but I'm still going to get the same place. Since it's exact, I'm going to take 1/4 times 2 times 10, which simplifies to 5 times pi, and we're dealing with our unit of centimeters. Okay, a couple more to try out. Here we're looking for the exact length of arc CED. CED, that's going to be a major arc. Okay, we notice here that we have 120-degree angle. That's a central angle. That arc CD is the same, so it's 120 degrees. So the stuff that's left over, 360 minus 120, I have 240 degrees. Okay. If I'm dealing with length equals fraction times circumference, I know that I have 240 degrees out of 360. We are told that the diameter of this circle is 12 feet. So in my toolkit, rather than the 2 pi r I've been dealing with every other problem here, I'm going to think about pi times diameter, so pi times 12. If I'd like, I can simplify this and say that 2/3 pi times 12. Okay. All right, so we see fractions, we might freak out a little bit. It's going to be okay. We can multiply the tops of our fraction, and we get 2 times 12, which is 24. On the bottom, 3 times 1, we have 3 pi. And we know that 24 divided by 3, that's 8 pi. And I'm dealing with feet. Okay, one more from the notes. All right, we're looking for the measure of angle AOB. I'm going to throw a theta in there. That's what I'm looking for. From the picture, I can tell that AB has a length of 4.2 feet. I can see here 4 is labeled, and that's indicating my radius. All right, so I want to find the measure of angle AOB, so I'm going to have a little bit of working backwards to do here. All right, so my length, I already know that piece. My length is 4.2, so I'm going to plug that in. My fraction, I don't know how many degrees I have, but I know it has to be out of 360. And then circumference, since I have my radius, I'm thinking 2 pi r, or 2 times pi times 4. I can choose to clean it up a little bit and take 2 times 4. So I have 4.2 equals theta over 360 times 8 pi. All right, my job here is to get theta by itself. So to get rid of that fraction, divide by 360, I might choose to multiply both sides by 360. 360 over 360 is 1. All right, so I have 1,512 equals theta times 8 pi. I'm lazy, I'm going to divide both sides by 8 pi all at once, making sure that when I hit up my calculator, I throw 8 pi into parentheses. And when I do that, theta is equal to approximately 60.2 degrees. All right. Now it's time to try some things on your own. So you're looking at section 5-7, trying 1 through 14, 19 through 24. All right, I know that we are bombarded with all this virtual learning business, so I'm giving you a 20-minute max on this homework. Whatever you can complete in 20 minutes is all you have to do. Now, that doesn't mean that you make a sandwich for 15 minutes and then you kind of check your Instagram feed for a little bit and then you try the math for a couple minutes. But if you're truly working on it for 20 minutes and it's not done yet, that counts as your attempt. All right. I had a request to go through a couple of the questions just to get you started on the homework. So I'm going to do that. This is available for you on Blackboard. So you can do it in Notability or you can choose to do it in Class Kick. If you keep scrolling down in this document, you'll notice that the answer key is provided for us at the end. All right, so just starting with number 1. We're looking for the circumference of circle O. We're leaving our answer in terms of pi, so exact answer. That means the same thing. I notice here, hey, that 15 centimeters, that's a diameter, so I'm thinking pi d. So pi times 15. Typically, we write the number first, so 15 pi centimeters. Okay, that's how we get cooking with that first one. Another type of question for you. Okay, number 9, we're looking for this, the circumference and the arc length of the red highlighted piece, and we're going to leave our answer in terms of pi. All right, I'm going to give myself a little bit more room, so Zamboni some space, and I'll take a look at number 9 with you. All right, number 9. We're asked to do 2 things. We want our circumference and our arc length. Well, I notice here that this piece here is 14. That's my radius. So for the first part, I'm thinking 2 pi r. So I'm thinking 2 times pi times 14. 2 times 14. Come on, stylus, you can do it. Maybe not. Well, I'm trying to highlight the 14. But anyway, 2 times 14, that gives me 28. 28 pi, and I'm dealing with centimeters. The second part says to find my arc length. Now we remember that length equals fraction times circumference. There we go. Well, it's underneath there. Anyway, length equals fraction times circumference. I'll abbreviate it. Okay. If I'm dealing with this piece, I know that I have 45 degrees, and my 45 degrees is out of 360. Okay, times my circumference. Well, I just calculated my circumference here, so I'm just going to plug that in. Times 28 pi. All right. If I take a look and multiply 45 over 360 times 28, I have 3.5 pi. It's kind of weird to leave a decimal connected with a pi like that. So I know that 3.5, that's the same thing as 7 halves. So 7 halves pi might be how I express that arc length. All right, that's what I have for you. Please let me know if you have any questions. Talk to you later. Bye.